So let's continue looking at states that are superpositions of energy eigenfunctions for the particle that's forced to live between 0 and L. And let's say that we construct a state, or that the particle is described by the following psi of x and t. I don't know, one... let's see, let's just do 1 over root 2, but not psi 1 of x, let's do psi 2 of x, e to the minus I e2t over h bar, plus 1 over root 2 psi 4 of x, e to the minus I e4t over h bar. We know that psi 2 and psi 4 are odd functions. So 0 and L, we've plotted these before, psi 2 of x, that goes like sine of 2 pi x over L. So, and we know that all these functions vanish at 0 and L. And this is the first excited state, so the lowest state has no nodes, just goes to 0 at the extremes. This one is the one with one node, so it goes to 0 in between. And so we have this odd parity, right? If we flip the function around 180 degrees from here, we have to multiply by a minus sign. So it's odd parity, and then the next one, we're going to move this over and produce an even function for psi 3, and then psi 4 again becomes odd. But considering psi star psi, then we end up with 1/2 psi 2 of x squared plus 1/2 psi 4 of x squared plus twice this times that. So that's twice 1/2, so that's 1 psi 2 of x psi 4 of x cosine of e4 minus e2 t over h bar, right? That's the angular frequency. So there's clearly time dependence, but if we consider, say, that, we know that we'll get 1/2, because we have odd times odd, that gives us even. And so all these functions are even. They can't discriminate one side of the well compared to the other, over the other. And so the probability must be 1/2 for that. So again, this integral, if we integrated this function from 0 to L over 2, or from L over 2 to L for that matter, this will also give us 0. We know, again, that these are orthonormal, so if we integrate from 0 to L, this has to be 0. And from 0 to L over 2, it has to be half of the total value, because both sides have to have the same value, so we have to get 0 for that as well. So the probability is 1/2. Now I just wanted to point out that if we integrate functions like this over a range, over some arbitrary range, say somewhere in there, right, over, let's pick a range there, that's, I don't know, L over 4 to something a little bit larger than that and less than L over 2, there's clearly time dependence in that term. We don't get a fixed quantity independent of time. So there's clearly time dependence in the probability density. And that will be revealed in the probability, but not if we have these symmetries or these parities and we go from here to there or from there to there in the probability. In that case, the probability of finding the particle is not time dependent.